Because I'm kind of thirsty.
Sure.
Friday.
Sure.
We're doing something on Friday.
Alright, are you ready? Yes, you are. Okay, here we go. See, now you're not going to fall asleep in class. It's perfect. You just do those every day. You'll be buff, you know? Okay? So, if you take the derivative a to x of f of t dt. Okay, this is the fundamental theorem. So, there are two. Obviously, we already learned one of them. We can write it over here to the side so you'll remember it. First is this.
Well, you should take like a whole class period to tell us about John Mark.
Okay, I'm recording. What if he follows me on YouTube?
You came over your house, right?
No, we were camping, you scrub. Camping. We were on a camping site. Okay? That hasn't happened yet. It's in the future. Okay? It's a planned moment. Okay? No. Actually broken. And I just have left that part of my sprinkler system turned off, so now that part of my grass is just dead. You know? But if I turn it on, then it just overflows and then my water bill's high. So it's like, you know, it's kind of in the back, you know. Less to mow, you know. Alright. So this is the first fundamental theorem. You remember this? Capital F is the antiderivative of little f. Do you remember this? Yes? Okay, so here's how you take the derivative of an integral. Okay, pretend like the derivative isn't there. And let's just work out this part using fundamental theorem. So the antiderivative is going to be, thank you, capital F of b minus capital F of a, right? Given this rule right here. So capital F of x minus capital F of a. Why is what? Okay, so notice the reason that the upper bound is an x is because that's what we had up here. Yeah? Okay. Okay, we're trying the whole little like groups just to see how it goes. Okay, but we'll see. Okay, so when I take the derivative now of both of these, okay, I'm going to have the derivative of capital F of x minus the derivative of capital F of a. However, okay, x is an equation, okay, but f of a is a constant. What is the derivative of a constant? 0. So that part is basically just going to go away. When you take the derivative of a constant, you just get 0. Now, one other thing. If it's the derivative of capital F, what's that called? Little f. Good. Good job, Yoel. Okay, so here is the rule. I'm going to write it over here on the side. This is really, really easy. Okay? The derivative from a constant to x of f of t dt is f of x. All that you're going to do is take x and you're going to sub it in where the t was. And the reason why, though, should make sense, that when you take the antiderivative but then you take the derivative, you're back with what you started. The constant just goes away because the derivative of a constant zeroes out. Yes, sir? Why do we use... Okay, because this integral was from a to b. So if these were both constants, the derivative would be 0. You would only use this when you have a constant on the bottom and a variable on the top. Okay? So if they were both numbers, the derivative of numbers is just 0. Okay? So this is the second fundamental theorem of calculus. Okay?
Fundamental theorem of calculus.
Yes. Alright, so here we go. Look at number 1. Okay, can you see this? Okay, so look at number 1. You have the derivative of an integral from a constant to x of a function in terms of t. All that you do is you rewrite f of x, but with an x instead of a t. So this is what that looks like. Okay, it's going to be x plugged in, x squared plus 1.
Wait, so we finished that? It just equals f of x?
Uh-huh. Well, and it's to shorten this from having to do this over and over again. So it's like a shortcut, kind of, if you will. Okay, because, listen, if I took the antiderivative of that, I'd get a third t cubed.
So that's all. We don't gotta do none of that. All we gotta do is.
So obviously it gets harder, but yes, for like a simple one, that's all you'd have to do. Okay? Now look at number 2. If I take this x and I plug it in, what would I have when I do the derivative of the integral? You got it. Okay, easy, right? Okay, now look at number 3. What is wrong with number 3?
Oh, it's backwards.
It's backwards. How do you fix if it's backwards? You put a negative in the front and reverse it. So this is the same as the derivative of the integral from 7 to x of negative y squared sine y dy. And it doesn't matter what your initial letter is, when you switch it out, it's going to end up being whatever this letter is, which is an x. So when I rewrite it, I pull that negative out to fix the order, then it's x squared sine x. Now notice there's no plus c because of the derivative. Whatever your c would have been when you take the derivative, it'll go away. Got it? Okay, so there are 2 ways that they test this on the AP test. Usually it's not quite this easy. Usually they'll give you an equation and they'll ask you to find a bunch of stuff, or turn the page, they'll give you a graph and they'll make you find a bunch of stuff. So we're going to practice both. The equation side, I think, is a lot easier. Okay, so if I'm doing this first one, I want f of 2. Okay, f of 2 is going to replace where x is in the equation. So what will my new integral be? 2 to 2. That is going to be 0. Good job. Okay, pi over 6t dt. Okay, now remember, why do we know that it's 0? Because if my endpoints are the same, okay, then you can't do it. Now, if it was anything other than 2, you would have had to actually do the antiderivative. Okay, go down to part B. This time we want f prime of x. So f prime of x means that we need to take the derivative. So f prime of x is going to be the derivative, d dx, of the integral from 2 to x of sine pi 6t dt. Okay, now you could do u sub, okay, and do the antiderivative and then take the derivative again, but that's a waste of time because we have fundamental theorem. It says that all I have to do is take this x, pop it in where the t is, and it'll come out the same. So I'm going to put sine pi over 6x. Now, the other thing they could ask you to do, like they did in the previous part, is to plug in a number. So if this is f prime of any x, now I want f prime of 2. Well, then that would be the sine of pi 6 times 2. Now, 2 pi 6 is going to reduce to be what? Pi thirds, good. Okay, 2 over 6 is the same as 1 over 3. So pi thirds is 0, pi 6, pi fourths, pi thirds is here. Sine's on the bottom, so it's going to be root 3 over 2. Very good. Okay. All right, go down to part D. Now I want f double prime. Okay, well think about it. If this is f prime, then f double prime is going to be the derivative again. What is the derivative of sine? This time you're going down, snow cone, snow cone. Okay, and then will I have to put anything else? Yes. Why would I have to multiply by the extra pi 6? What rule is that? Chain rule. Okay, so when I take the derivative of pi 6x in there, it gives me an extra pi 6 in the front. That's your chain rule. Okay, then in part E, we want f double prime at 0. Well, then I'd plug in 0 to the center and then just evaluate. Okay? So it'll be pi 6 times cosine pi 6 times 0. But pi 6 times 0 is really just 0, and what is the cosine of 0? Yep. So if it's the cosine of 0, that's really just 1 times pi 6th, which is pi 6th. Got it? Okay, so notice obviously the difference. If you're doing it with x, it's going to stay an equation. If you're plugging in a number, you should be able to evaluate and get a specific number. Okay, we're ready to do some FRQs? Okay, turn the page. Alright, take a look at your graph. What is this a graph of? What function? F. Now, what are they asking me for in parts A, B, and C? Are they asking about F? G. That's how you know you're doing fundamental theorem. This is a graph of F. They're asking you questions about G. Do we have a graph of G?
No.
No. If we did, we'd be looking at that graph, but we have F instead. So, look over here. Tells me that g of x is the integral from 0 to x. So if I want to find g of 2, just like we did on the front, I would take my 2 and I would plug it in where x is as the endpoint. That's the letter I'm replacing, not the letter in here. So I would go from 0 to 2 and then f of t dt. Now, how do you do an integral of f if you have a graph? You know it. Area. Good. So, look at your graph. From 0 to 2, I'd be accumulating this triangle above and then this triangle below.
It's just 0, right?
It's going to be 0 because those areas are going to do what? Cancel out with each other. Okay, good. So when I do g of 2, I get 0 because my area on top and on bottom cancels out with each other. Okay, next I want g prime of 2. And then after that, I'm going to find g double prime of 2. So let's take a little break here and go to the top of the paper. We're going to take the derivative, then we're going to take the second derivative. So g of x is right here. It's the integral from 0 to x f of t dt. G prime of x is going to be the derivative of that. And we just learned that rule. When I take the derivative of an integral from 0 to x f of t dt, what do I get? It was on the front, f of x. Good. So if I want to find g prime of 2, based on second fundamental theorem, I really just want f of 2. So look at your graph. What is f of 2? Meaning that would be the y value, which is -3. Very good. Make sense? Okay, next I want g double prime. So think about, if g prime is really just normal f, then what will g double prime be? What's the derivative of f going to be called? It'd be called f prime, right? And now if this is a graph of f, what characteristic will that be?
Concavity.
Not concavity. Slope. Because remember, if this is f and I want f prime, that's going to be the slope. Very good. So look at 2. 2 is here. What is my rise over run from this pretty point to this pretty point? Down 3 over 1. So that'd be -3. Now, okay, what Sean said I think is a good thing to remember. It is concavity, but of which graph? It's concavity of G, and we don't have a picture of G. So that's why when y'all think it's like so extra that I say like, when you put the slope changes, and I'm like, nope, it matters. Is it the slope of G, the slope of the graph of F? We don't know if you're not specific. Okay, so let's go to part B. So I want G of 0, G prime of 0, and then G double prime of 0. Okay, so let's do G of 0 first. Now remember, G has an integral in it. So you're doing area. It'd be the integral from 0 to 0 of f of t. That's one of your special rules. Whenever they match, what is it? 0. Now I want g prime of 0. So I'm going to take my finger from g down to g prime. What is g prime in the graph? F. So really I just want f of 0. Look at your graph. What is f of 0? 3. Very good. And that was the y value, right? Okay, next I want g double prime, so I'm going to come down to this third one. G double prime is the same as f prime. So I want f prime of 0, which is the slope of the graph that we're looking at. Okay, look at 0. What is my slope at that point? Why does it not exist? Because it's a corner. Very good. Now remember, the definition of a derivative is the slope from the left and the slope from the right have to be the same. What is the slope on this side? Positive 3. What's the slope on this side? Negative 3. So if those limits don't match each other, that's why you would say DNE. Okay? Alright, last one like that. Take a look at part C. We want g of negative 1. G prime of negative 1. And then g double prime of negative 1. Okay? So I'm starting my integral at the same value, which was 0. So 0 to negative 1 of f of t. Okay, now, Marcel, what do you notice is different about this integral than about the other two integrals?
There's a negative.
Okay, there is a negative, and look at the order. Normally the smaller number's on the bottom, the bigger number's on the top. Is that the case here?
No, man.
Okay, no, this one is backwards. Okay? So when I find the area, I'm going to have to remember to go back and change the sign. Okay? So 0 to negative 1, take a look at your picture. Okay, it is a triangle. What's the area going to be? 1/2 base times height. Okay, ladies, you with us? Okay, so it's 1/2. My base is 1. My height is 3. So that is 3/2. Thank you. Thanks. And although the area is positive 3/2, the integral is going to be what? Negative 3/2. Okay? Alright, g prime of negative 1. What are we going to get there? Look at your graph. G prime is the same as f. So now I want f of negative 1. Okay, f of negative 1 is going to be the y value at negative 1, which is what? 0. And then g double prime of negative 1 is going to be f prime of negative 1, which is the slope, which is the slope of negative 1, which would be 3. Okay, guys, come on. Calm yourself. Rest your breast. Rest your breast. Okay, go to part D. We want to know when G is increasing. So this is where you have to think about. For G to be increasing, what does G prime have to be? Okay, G prime must be positive. Okay, and if G prime is going to be positive, what is that in the graph of F? G prime is the same as the... Nope.
Derivative.
Oh, okay. All wrong. No. Okay, F. Thank you. It's a long way. Okay, that is correct. So, G prime in this graph is really F of X. So if I want G prime to be positive, I need the Y values of F to be positive. Where are my Y values positive? Negative 1 to 1. Very good. Okay? So negative 1 to 1 because G prime, which is really F of X, is greater than 0. And you have to make the connection between what you're talking about in G and what you're talking about in the graph that you're actually looking at. Okay, go down to part E. Now we want critical numbers. Okay, critical numbers are going to occur when g prime of x is 0 or undefined. Now remember, this is not a graph of g. This is a graph of f. So g prime is the same as f. So where are my f's going to equal 0? At what two values? -1 and 1. Those are my critical numbers. Okay, then you'll notice that next they're going to ask me to label it as a minimum, maximum, or neither. So if I look at my graph here, what type is -1? A min, max, or neither?
It would be a
Min. What is 1 going to be? A max, because of the direction of the sign change. Okay. So I'm going to put x equals -1 and x equals 1. I'm going to list them separately because they're different types of extrema. -1 we said is a relative minimum because g prime, which is really f of x, changes from negative y values to positive y values. Okay? And then positive 1 is going to be a relative maximum because g prime of x, which is f of x, changes from positive to negative. Okay, next one, we want concavity. Okay, G will be concave down when what has to be negative if I want concave down? For G. Would it be G, G prime, or G double prime? G double prime, but what will that be for F?
F prime.
F prime. Okay, so I'm going to put over here, I need G double prime must be negative. But then I have to remember that I'm not looking at a graph of G. I'm looking at a graph of F. So that's where you have to make that connection. G double prime is really F prime. So F prime in the graph is the slope. So look at your graph. When does the graph of F have a negative slope? 0 to 2. Okay, because G double prime of X, the slope of F is less than 0. Now, if you want to put G double prime of X, which is really F prime, that's fine, but you have to say the slope of F. Okay, because that's the connection there, is that that's what F prime is. Okay, go down to part G. Now we want points of inflection. Points of inflection are going to occur when G double prime changes sign. Okay, but remember, we don't have a graph of G double prime, we have a graph of F. So if G double prime is going to change sign, what characteristic are we looking for to change sign in this graph? This slope. And it could change either way, it just has to change. So look at your graph, put in X where the slope changes sign. The slope changes sign where?
3. Or 0, x equals 0.
At 0, very good. So put in X right there, that's going to be your POI. So you'd put X equals 0. G double prime, the slope of F changes sign. And then remember that for mins and maxes, you have to state the direction, but for a point of inflection, it actually doesn't matter. It can change plus to minus or minus to plus. Okay? All right, the last part, part H, they ask you to sketch a graph. Okay, we are going to do that after doing our first and second derivative tests. So set up for me a first derivative test.
How do you do that?
We're about to do it. Yep. So I'm going to put G, G prime, G, G double prime. Now remember that when I'm looking at the graph, I'm looking at the graph of F. So I have to remember what the connection is between those two. When I'm looking at G double prime, that's really what? So look at your graph. When does f hit 0? It happens twice. Okay, -1 and 1. And before -1, is f positive or negative? Is it above or below? Before -1 in this first interval. Okay, look at your graph. Where is it? It's negative. Then where is it? Positive. Then where is it? Negative. So it should be plus minus plus, which tells us what about g? It tells me that g was increasing, decreasing, increasing. Now, for the second derivative test, I'm looking at g double prime, but that's really f prime. Yes? Yeah. So this is -2 on the end point, and this is 2. Yeah? Okay, so look at your graph. Where did we say the point of inflection happens? At what number for the second derivative? 0. And then remember, you want to try to line your graphs up with each other to make sketching easier. Okay, on the left side of 0, was your slope uphill or downhill in the graph of f? Okay, I had a positive slope, then it changed to a... Now, if this is g double prime, what does that tell me about g? Concavity. It's concave up, then it's concave down. Okay, so now let's sketch. -1, +1. Now, the other thing I want to remind you of is that just like on the slope fields, when you had to draw the picture and kind of follow the curve, okay, it's the same thing here. As long as your graph is shaped right, it doesn't matter how far up or down you go. You just have to make sure you're following the shape. So from 0 to -1, my graph should be increasing and concave what? Up. So I'm going to go like that. Increasing, concave up. I'm sorry, I said that wrong. From -2 to -1. So this first chunk of graph, I need to be increasing, concave up. Okay, now I'm going to look now at this section. From -1 to 0. What is my graph doing? It's decreasing, but it's still concave up. So when I do my graph, I need to be decreasing, but I need to stay concave up. So wait, did I do that right? Increasing, up, yes. And now we need to be decreasing, but up, so like that. Okay, then at 0, what's going to happen? I'm still decreasing, but how am I now? Concave down, so like that. So I'm decreasing, but now I'm concave down. And then for my last little chunk of my graph here, I need to be increasing, but concave down. So like that. Okay? Yes? Did I write it backwards? Okay, I was going to say that graph did not look... Oh, tragic. Y'all, look, I put plus, minus, plus. It was supposed to be minus, plus, minus.
Miss, it's too late now. Just leave it.
You're, I'm going to fix it. I'm going to do it in this green. Look, see, if you guys told me minus... No, you, hush. You did not.
Either way, if we correct you, we're usually wrong.
That's true. It depends who it is. Okay, so I'm going to just redo it. You don't have to if you don't want to. I don't care. But, okay, so I'd be going down, concave up. So that'd be like this. Then I'd be going up, concave up. That would be like this. Then I'd be going down, concave, down, which would be like down, concave, down, like that. And then I want to go up, concave, down, which would be like that. So it's basically just a flip of what we just did. Okay? Great. I think I did that wrong, but it's fine. We messed it up. Okay, ready? Next one. That was fun. All right. What I want you to do now with your little shoulder buddies is parts A, B, C, and E. Okay? A, B, C, E. You can do it. Okay? A, B, C, E. Okay, turn it over. Let's go. Next one. Okay, so look back. Marcel, focus. Marcel, focus. You were really on your game there for a while. You're falling off. This is why I can't put on. She already had one. I had him last year. Wait, y'all are still He said to let you spit your game, let you shoot your shot. So now let's do part A.
Wait, what's next?
It's empty, bro.
Hey, by the way, does anyone want some?
By the way, do part A. How about that work? Put your drugs away.
You hear me? Why are you a snitch?
Snitch on what?
Who you snitch on what? You just stole that.
That wasn't it. Was that a secret? You said it out loud.
Honestly, there's only 3 people that heard that. Just you and your well. And you're like,
Yeah, no, so it's
I don't know.
It's hilarious. Okay, what are we doing, people? Yes, good. And then from 2 to 6, we find the area. So shade from the integral from 2 to 6. Shade from
Let's go over Daisy.
okay,
I've been taking
All in your mouth.
I've been at people.
Like they take a huge chunk off and it's like up to here.
Wait, will we get one taken off if we don't do that?
It's like sticky.
Like for all of them? Like I think that one. I did it right.
you are Gucci, but you need to write your...
It's like
I'm just saying like, I'm just writing it up.
it's like
Yep,
red.
yep.
Like I know like here I didn't do it right, but like for these should you gotta write it out? Or like this
So that's where I can't answer that because some years they make you write it, and then other years they don't. So I would just say as a good practice,
Okay, no.
because if they give points for that interval being set up, then you use versus if you just bite the bullet and do it. Okay, how about
You're pregnant orders.
you guys are good for invitation now? Yes, let's do part A. You're taking your 6. So it'll be the integral from 2 to 6. Yes.
Like I listened to the first time. What's
The height.
What's
the height?
No.
4.
So, but if we count these, how many it is? Like, you can count here.
Uh-huh.
2 and this will be 4.
Okay, if you need help on part A, okay, your G of 6 would be the integral from 2 to 6 of f of t dt. Okay, and then in your graph, you should shade between 2 and 6, and then find the area of that, which somebody said is 8. That is correct.
Like at first I liked it, and then I loved it.
Okay, then for G prime of 6 and G double prime of 6, I would stop, find G prime, and then find G double prime. So I found the area, so 2 to 6 is this triangle. So it has a base of 4 and a height of 4, so that's 16, then cut it in half. Okay, and then when you get to the derivatives, I would stop and rewrite G of x, G prime of x, and G double prime of x. So if G is from 2 to x of f of t, then what would G prime be if it's the derivative of that integral? It would just be f of x. And then if I took the derivative one more time, what would I get? F prime. And so then what I'm going to write next to this, just because sometimes it helps, okay, is that this one is area. This one will be the y values. And then this one will be the slope. Okay? So if I'm doing g prime of 6, that's going to be f of 6, which is 0. Very good, because that's 6. My y value is 0. Okay? Then for g double prime of 6, I want the slope of that line segment, so you just pick another pretty point, count the slope. So if I'm here, my rise over run is down 4 over 2, so it's negative 2. And oops, I should have written f prime of 6, which is negative 2. Okay? It's not that much. Okay, so for part B, you want g of negative 2. So g of negative 2 is the integral from 2 to negative 2 f of t dt. And as I shade from 2 to negative 2, I notice that my triangle is the exact same size. So should I put 8? No, I shouldn't. Negative 8, because why? It's backwards. Okay, so even though your area is still positive 8, because you're integrating backwards on the number line, that counts as a negative 8. Okay, then your g prime of negative 2 is f of negative 2. And looking at negative 2, what's your y value? 0. Then I want g double prime of negative 2, that's f prime of negative 2, which is the slope. And what is the slope at negative 2? Positive 2. Very good. That's the slope. That's the y value. That's the area. Okay? Alright, from there we're finding critical numbers. Okay, critical numbers are going to be the x-intercepts. There are several, so let's label them before we write them down so we don't have to explain things over and over again. So look at your graph, put dots on all the x-intercepts. Which one is going to qualify as a max? 6. X equals 6, relative max, because g prime, which is really f, changes positive to negative. Okay, so 6 is good, 6 is a max. Where is my min? Negative 2. Because g prime, which is really f, changes negative to positive. Okay, then there are 2 other x-intercepts. Okay, they're both neithers. Are they still critical numbers? Yes, but they're not extrema, because extrema means only mins and maxes, right? So where are my 2 neithers? 2 and 10. Very good. So I would say x equals 2 and 10. Those are both neither, because g prime of x, which is f of x, doesn't change sign. Okay? One of them it stayed above, one of them it stayed below, so that doesn't count as a min or max. That's a neither. Okay, now part D, notice the difference. Relative max, relative min. In part D, it asks you for the absolute extrema. What's the difference? You have to do a candidate's chart with what in it? The endpoints. Very good. Now you'll notice I copy pasted this and put the wrong interval, so change it. It should be negative 4 to 12. Okay, so let's talk about that. Let's set up our chart. What critical numbers can I leave out of the chart? Yes, 2 and 10, I can leave those out because they're what? They're neithers. We know they're not going to win. So when I set up my chart here, I'm going to put negative 4 and 12. I'm going to put negative 2 and 6. But I'm not going to list the two that are neithers because I know they're not going to win. Now, if I'm finding maxes on G, then you need to make sure that you label your table as G of X. Okay, so we're not using F, we're using G, which had the integral in it. Now, did I already find two of those numbers? In part A, what did I find G of 6 to be? It was 8. And what did I find G of negative 2 to be? Negative 8. Okay, so those I had already found in parts A and B. Okay? So you want to make sure don't redo a bunch of extra work. You want to try to reuse what you've already done. Okay, so there are two parts I have to find. I need to find G of negative 4, and I still need to find G of 12. Let's do negative 4 first. That would be the integral from 2 to negative 4 of f of t dt. Now, what is the first thing you notice that's wrong with those endpoints? 2 to negative 4 is backwards. So when I find the area, I'm going to have to remember to change the sign. So negative 4 is back here. 2 is all the way up to here. But what do you notice is going to happen with this piece of the triangle and this piece? These two pieces are going to add up to how much? 0. And then this piece left over, if it's half of 8, it'll be 4. Now, my leftover area is above, but it was also backwards. So instead of putting positive 4, I'm going to put negative 4. Okay, this was negative 4. Because two of my triangles crossed out, and although the leftover one was on top, it switches to negative because it was backwards. Okay, then G of 12. Okay, I'm not integrating until 2, so that's here. What's going to happen with this triangle and this triangle? With these two? Cancel out. I have a little baby triangle left over. That's 4, but it's 4 below. So it will be negative 4. So then I would write my absolute max is 8 at 6. My absolute min is negative 8 at negative 2. Okay? Okay, and then we'll have to finish the other two next time because it's 11:47. Good job, sort of.